Well, welcome. We are down in Plainfield, Indiana, outside of Indianapolis, and we're down with Adam here at ID10T Design. Adam, we met in February, was that March, at a progressive show, and we've been, it's a kind of a fortuitous meeting, and learned a lot about some of the stuff that he does, which is, you've done all kinds of work.
Yeah, it's a lot of production-based stuff from weldments, fixturing, machine, CNC machining, fixturing, as well as tooling, and then just product design. A lot of its background is exhaust-based in the motorsport world. So
you definitely see a lot of motorcycle parts around here. I have been designing over the last number of months the frame and rear suspension for the Halcyon 450. And so what we're seeing right here is what I've been working on in, as you can see up here, in CAD, actually coming into life, which is where Adam comes in. Adam is taking our 3D designs, our virtual designs, and turning them into something we can actually hold on to and take a look at. So right here, this is the rear, essentially it's a swing arm for the Halcyon 450. It's modeled after a number of designs, but it's called a cantilever rear suspension, and we were really thinking about the Vincent HRD rear suspension, especially when I came up with this. But it's really neat to see it here. This is not only the finished part, but you have the tooling as well.
correct, yeah. So everything can be made right in the fixture, welded up. I'm sure there's certain parts of the welding after you do probably 80% of it in the fixture you can take out, set some stuff up and do the finish welding, the last 20%. I think the easiest way to explain fixturing, tooling, is when you've got a component that you're trying to be repeatable every single time it's made. Kind of like the whole thing with McDonald's and their fries. You can go anywhere and they always smell and taste the same type of thing. Fixturing is kind of the same way. You want it to always be right on the spec of what the customer is asking for as far as what you're making out of it, but always be repeatable every time it's being used as far as the component that you're making. Because the end user, when they trash a swing arm, they want to go and buy a new swing arm. They don't want the company to go, oh, can you send us your frame so we can make the swing arm fit your frame? Because we don't have a fixture.
So in this example here, what is this all doing? Like the piece, these different parts.
Okay, that's pretty easy to explain. So the component that actually locates this guy, that always comes out, which that's another part I'm going to probably start thinking through. But so that guy locates this up here. It also, this little bar right here just kind of gives you a rest for this guy to make sure it's at the right angle. As well as, there was one other, this little guy right here, which could just be a pin, but I had all this all thread, so I used it. It located this.
Okay.
So this encompasses 1, 2, 3 parts, component-wise, all into one fixture, which makes it nice. And that was the design intent for this guy. But in order to make sure that this is in the right location and be able to take this out, this guy has to be able to come out. Yeah. I could have probably spent a little bit more time, and this would always stay in the same spot. And like I said, production-wise, it probably will. And it may change the orientation of how this goes, but for right now, that's the way this is designed. I'm always learning new things, especially as technology gets better and better in the industry for manufacturing. Having a background in R&D and product development, there will be changes. There always is, especially after you've released something to manufacturing. Sometimes you catch stuff out in the field that you just have to make a revision for. It's not going backwards, it's usually going forwards to improve a product. So you kind of have to forward think a lot of that stuff, and that's why I make a lot of the tooling now more modular, you could make the tooling to where it's all encompassing into one solid piece. Well, if you got to make a change to something, you got to go back, you got to cut it out or redo that whole thing, and it's not beneficial to the customer. And sometimes the customer doesn't even know that. My thinking is well, why not make it more modular to where if it's just one component that they're changing or just a few, you're just changing out that part, and it's a redesign for that one part. And all those adjustments can be made in CAD because it's already been documented in CAD. So
yeah, you should mention that like one of the first things you sent us is not this, it's
right.
The CAD model of the fixture.
Correct, yeah, with this in it to kind of give you an idea as far as, okay, this is what you're looking at. It gives the customer a complete visual, especially if they're already working in CAD, to sit there and rotate it in their software and look at all the different aspects of it and see things that maybe I missed or that we can improve upon and work together on.
When we're both able to see the same thing and actually work on a visual or a virtual model, it really makes it very easy to do. It's
been actually really fluid and really easy with Richard, because as soon as I've come up with something, I can send it to him right away and he can check it out. Pull it up, we can both have it on our screens, and we're looking at the same exact thing and going through it step by step. So Richard would basically come to me and say, hey, we've got this frame and what he calls the rear transom setup on the back of what I call is the rear swing arm, but he calls it the transom. Basically those two components with the tabs that he's currently already got set up, I'll take a look at it, evaluate what type of fixturing it would need to weld it together, as well as create those parts. And I'll myself in CAD will create all the fixturing that you see around the shop to build those components. Things that I keep in mind are tolerancing on the bending side for the tubes, that a welder can actually get to those joints that need to be welded, clearances, as well as just feasibility when you're working with the fixture and you're making the parts themselves. I try to think about globally about everybody that's involved in that. From a design aspect, because I've worked in the industry long enough and been on the actual ground floor building parts before and know the frustrations as a welder as well as a designer. So I try to merge those two things together and try to come up with a good end product for the customer. So I try to get a lot of feedback as well and asking questions like, what is the true intent for this part, as well as how many pieces you're going to see come in and out, and then make your tooling a little more modular too. Things wear out, and work through that as well.
And so, you visited, we went and gave you a tour of our fabrication shop, which is, as you all know, an Amish shop. So learning a little bit more about how they do things, and how Adam does things and merging those together. You also talked, we've redesigned a number of parts of the bike based on Adam's feedback. So instead of doing different bend radii around this, we're working toward having a single bend radius just to make it easier for actual production. We've also kind of on the fly redesigned just because the rear portion of the frame, because we were simultaneously working with our suspension designer and trying to build it, and realized that we just needed a little bit more clearance. And Adam's been awesome at kind of adapting to that as we go. And there will be more adapting required, because what we have here, right in front of me, is this main frame, half of it, and what we've kind of agreed to do at this point is just kind of the basic frame, and there will be a lot more brackets and tabs and parts of this frame that are going to need to be added to it. So this will be like the very first prototype version. So so this frame, probably the first thing that when I walked in this morning that I was just like, wow, and you'll probably notice as well, is that this is not, this is a bit much beefier frame than our 250. This frame will be built out of 1.25" tube, so it's got a much beefier kind of profile. And also, we are working on making this a more modular design. So as we launch the 450, we're going to come out with first just the Halcyon. That's quite enough work to do one model in a year. But then we're designing this so that the Phoenix and Griffin can also potentially be built around the same frame. Now, with the 250, that's also the case, but there's a completely different back end of the bike between the hardtail and softtail. They both will be softtails, or all three models will be softtails, but this one will actually be the same frame that works on all models. So that's a difference. And then probably another difference, and I don't know if you can see or visualize with this, is that our 250 uses a very traditional, it's essentially the Norton featherbed frame. And what we've done here is a little different. It has a rectangular down tube. So instead of having two tubes that come down and just keep going around, they join into this. And that's for a couple of reasons. The 450 engine that we're going to be using it has two exhaust ports, and in order to get those out, they would come right into where those tubes are. So we need to have a way to navigate that. With the previous two renditions of the Halcyon, for example, let's just say, my design process has dramatically changed, or let's say developed, and so we started off with like 2D drawings that, 1-to-1 scale that they would build off of, and everything was basically designed and built on a weld table. And what you end up with is, in that case, the most extreme example is completely different than what you had in your mind. With the 250, even though I designed it all the way through, when it was finished as a physical welded up frame, there were minute, well, sometimes not minute, but many differences as built compared to the design. And one of the things that Adam is bringing to this is the ability to then help us make sure that our designs at the end are going to still match what's as built. Everything kind of comes together and you're taking into account the whole process, not as an afterthought for production. It's going to make the rest of the design and development process a lot more simple.
So yeah, the prints, as far as for this project, I take your prints and go through them. Initially, it's kind of like, well, let's see what type of tolerance we can hold and we want to hold, and what's going to be the reality of it, and then readjust from there on a weldment side. Like this one's right now tacked together. I got to take into account, well, things are going to shrink when they're welded. So what can we do to not maybe prevent that from happening, but control that a little bit more after the fact? So that's what I've done with the fixtures. So on this back end, it's using traditional all thread. It's putting pressure. If this is called out at 10.5 inches, I'll basically spring it out probably to 10 5/8, because I know after it's welded, it's going to suck in a little bit. So that tolerance comes into tolerance. So you're not having to do another post process afterwards.
And as we've learned, if anything, you want it just a tiny bit out so you can get the wheel in.
Yeah. So with this design, most swing arms too, they do spring when they were being welded, wherever the joints are going to be. So, you don't want to do a bunch of those extra processes. It's time, it's labor, it's money. So I try to take into account of all that stuff.
And the more that you do take that stuff into account, the more that our design model, for example, I can continue to use that to design additional parts and rely on that to be somewhat related to the finished product. So I can still be designing parts that in the model that will match what's going to be on the bike. That's the problem I was kind of running into with definitely on the 250 is any designs that we had for it you can't really rely on them because they're different than as built. So you kind of have to redo the whole process to match what's built. And so The goal with the 450 is everything will be matching, and I can have a virtual model of everything, and I can go in and take measurements. I can add a part, change a part, and know that I'm going to be able to rely on that to line up.
Yeah, and then when you start going into production, at least on the quality side, when you have a model and you've already proven that the model is what you're getting, and that proof of concept is you can do on the quality side, you can scan, you got 3D scanners that are available nowadays,
Oh, yeah.
as well as other forms of equipment to where you can compare it to the model
For quality assurance.
For quality assurance, and then see if there's a deviation somewhere that's out of spec that you've inputted in. Like, you want this to be within, say, 60, 70 thousandths, so your assembly guys, when they go to throw it together, aren't sitting there, oh, I gotta open this thing up a little bit more, break out the hammer. And initially, this design, as far as on the fixturing side, I don't like to use the word quick and dirty, but I wanted to make sure you had something in your hands right away. So the current design right now that you see before you isn't going to be the exact production tooling. This is to make your prototypes, to kind of prove out what you have right now, and then we go back and see, okay, what can we improve on the tooling side? Because
some of this we may move on to production.
Yeah, some of it may and some of it may not. So like right now, you see kind of like the all thread in certain places, the dowels kind of just there. That is what we came up with quickly, to not spend too much time on just tooling and fixturing.
What are some concerns, like when you go to production tooling, that you're going to want to improve on based from this?
I want to be a little more modular than what we have here, or look at the longevity. In the short term, it's like, oh yeah, this could be consistent for a couple of parts, but if we were to make 50 to 100 whatever batches over and over again, things are going to wear out. And I know I said earlier, well, as things wear out, we can just change them out. Yes, but on this stuff, the whole intent for this was to just make something to where it assembles quickly, we can make a part quickly, and then move on from there.
So on this fixture here, what would be a part that would wear out that you'd be concentrating on to make more replaceable?
These aluminum bungs, for one.
Same with the rear
Yes,
axle?
same with the rear axle. Those would wear out. The all thread that I used up here is used 2 parts right now. It's basically aligning these plates when I assembled it, as well as compressing into this square tubing. Going into production tooling, there won't be any all thread. The components will actually be purpose built for the fixture. Probably a little more beefier, in all honesty. Just in case a guy is transporting the tooling and it drops.
Yeah.
Hey, let's be honest, it happens. Accidents happen, so you got to think through that stuff.
Well, thanks so much for watching. Please stay tuned for more episodes in this series of the development of the 450, and thanks for watching.